the results of frequency response from the monitors left and right, we can be seen the following. I'll show you in the following picture here. The first one is going to be our left monitor with no EQ, and right here we have the right monitor with no equalizer too, right? And here is 63 hertz, and we have with the sub. Here's with the subwoofer, and here with EQ, a little bit of EQ, and 125 hertz maybe, and a subwoofer. So it's pretty flat. It's a lot flat. This house curve here, even with a little bit of EQ, that makes a lot easier to monitor, to mix on this position here. So next picture I'm going to show is the operational response curve, and we can see that it dips a little bit in 125 hertz in our right monitor, and a little bit in our left monitor, and a little bit in 50 hertz in the right monitor. As the EBU says, to get all the points within the tolerance margin is quite difficult. It is common to use an equalizer, and we use a little bit in this room. We use a little bit for equalizer. The results were significantly similar above 160 hertz due to the geometric symmetry of the room. The frequency response from the left monitor drops 3 decibels below the tolerance at 125 hertz. Since we have plus or minus 1.5 decibel variations from the monitors, the measured curve exceed 1.5 decibel. The right monitor was a bit flatter in that position, but drop below 63 hertz. Frequency above 160 hertz show results within the measured range. So right here we can see in black, this line in black here is the tolerance and the upper limit, and we have another limit in red is the red line, okay? The minimum tolerance. The control room has a volume of 104 cubic meters. For this volume, the calculated TM is 0.253 seconds. This is the value used to set the maximum and minimum limits exceed for the reverberation time in the control room. So another figure here I want you to show is the reverberation time. This figure graphically shows the results, the measured results of reverberation time in function of frequency in the control room. Again, the black line is the maximum, right? TM maximum. And the red is the minimum, TM, right? The tolerance, again. The reverberation times is within or very close to the recommended tolerance range. We have just in here in 60 hertz, and the right side just a little bit, 0.05 seconds more. The ETC graphically shows the behavior of the room's first reflections at the position evaluated. The ETC was measured separately for each audio monitors from the reference listen position, since for each monitor position there are different reflections involving environment surfaces. The energy time curve of the control room from left and right monitor is shown in the next two pictures here. Okay, monitor left and here monitor right. Point A corresponds to the direct sound between the speaker and the microphone used for measurement, and point B and C are the highest amplitude reflections. The EBU recommends a minimum tolerance of 10 dB, 10 decibels between the direct sound and and the sound reflected in the first 15 milliseconds. The left and right monitors show a difference near to 20 decibels between the direct sound and the highest amplitude. We can see here its left monitor is 17.2 decibels between A and B and C. And right here, our right monitor is 20.2 decibels between the direct sound and the reflected sound. The ETC results are also presented in the function of frequency. Analyze the graphs. This is the waterfall graph. We see that the energy time curve between the frequencies is not linear. For frequencies above 8 kilohertz and around 500 hertz, the energy decays before the other frequencies. The resulting measurement of the background noise in the control room can be seen on the following graphic. There's another graphic here. And these values are the average of the three measuring points. The computer used by our engineer used to be inside the control room. It was right after we measured here, we move it to the machine room, where accommodate the power supplies and noiser equipment. The background noise of the control room was measured with the computer inside the control room and also inside the machine room. That's why we have two results, as we can see in this picture here. All right, the black line is with the computer in the machine room, and the gray line is with computer here inside the control room. EBU recommends that the background noise inside the control room should be lower than NR15 curve and preferably lower than NR10. And the P&E Wing recommendations for surround sound productions recommends that the values should be lower than 25 dBA weighted. In the case of EBU, the result found with the computer in the machine room is slightly high at frequencies above 5 kilohertz. This increase probably came from the air movement, since it was set up with the greatest airflow and lower temperature as the EBU recommended. It was freezing here inside, it's a powerful, very powerful air condition. So we were freezing. I would like to measure this room with a normal temperature and check how would the result would be. But since it was academic evaluation and for a phase, we had to follow recommendations, of course. Background noise measured in control room was within the values of NR20 curve, but I think it would be NR15 or 10 with a normal temperature. With the computer inside the control room, the sound pressure level at 125 Hz increased by 22 decibels, which results in the NR25 curve. That's a lot, 25 decibels from one computer. That means a lot. In this studio, there are other power supplies in the machining room, apparently noisier than the computer, which confirms the importance of the machine room. The P&E recommendations for surround sound productions recommends a sound pressure level value less than 25 dBA weighted. When the computer was moved into the machine room, this value was 17.1. This is 7.9 dB below the recommended tolerance range. With the computer allocated in the control room, the level of the background noise increased to 26.1 dBA. This value exceeds the recommended tolerance range by 1.1 decibel. This result shows how important the machine room is and that a single computer can make a very significant difference in the resulting background noise. The Schrodinger's plot from the control room is shown in the next picture here, the control room presents a linear energy decay with the exception of the first 10 milliseconds, where there are almost no reflections. And I also would like to show another recording studio where we have a nonlinear decay curve. In this case, the Schroeder's plot will reveal an issue that wouldn't be perceived using parameters like T20, T30, or the EDT, energy decay time, or ETC, energy time curve. The next table summarizes the measured acoustic results in the control room and verifies the requirement in accordance with the technical recommendations adopted. The operational room response curve exceeds the tolerance range of the recommendation adopted, but only at a frequency below 160 Hz. In this control room, the elevated value for reverberation time was less than 0.02 seconds. So we have 1, 2, 3, 4 marks that did not meet the specs. The rest is all fine. Energy time curve was satisfactory for both monitors in the control room. On the front monitors, the result was close to twice the minimum recommended value. Although very quiet between the frequency of 31.5 Hz and 5000 Hz, the background noise exceed the recommendations from EBU in the region of 800 Hz. The room size, ceiling and the height, and symmetry are within the recommended conditions, as well as the provision of audio monitors in the control room. So that's the end of the video. I hope you guys enjoy and like it. It was really a pleasure to share all the research I did for like 4 or 5 years. And I hope it's going to help your control room too. Thanks for watching it.